Hello everybody, today we'll be creating a tic-tac-toe game from scratch. I advise you to prepare yourselves because this is going to get very, very intense. So, the first thing we want to do is we're going to make a board recipe. We're just going to do recipe board and we're going to give it some attributes. We're going to have a two-dimensional list as the board representation. But now let's make it one-dimensional. Basically, we're going to start with 9 zeros. Like that. It's going to be a list of 9 zeros. Each one's going to represent a spot. We're going to have 1. Every time we want to place an X, we're going to have 1. Every time we want to place an O, we're going to have 2. We're going to have a place method. And we're going to have a win method that's going to check if anyone's won. So let's start. First thing we're going to want to do is we're just going to want to declare our board attribute. Let's start with an underscore, so it's private and shouldn't be accessed. Let's create our ingredients. And I'm actually going to add one more here, and I'm going to call this win conditions. And so in our ingredients, we're not going to take in any values. We're just going to be initializing these. So we're going to do attribute board, and we can do a for loop. We're going to do for I. Now what this does is it just returns a list of 9 zeros, because the one line returns whatever this is, and it executes it 9 times. So we're just going to end up with 9 zeros. So next thing we're going to do is we're going to be initializing our win conditions. Now, that's pretty simple. We're just going to have to make a really long list. So let's just create a list like that. And this is just going to be the indexes of every placement. So our first list is going to be 0, 1, 2. Because that'll be the first row. This is a list of lists. And so this is just going to be a list of every win condition. I'll link to a GitHub repository with all the source code for every tutorial. So you can just copy the win conditions so you don't have to type all of this out yourself, because that wouldn't be very fun. 036, 147, 258, and finally the two diagonal ones, which is 048 and 246. Okay, so these are all our win conditions. It says there's an error. There shouldn't be, but oh, comma. Oh, comma. There we go. All right, so first, let's create our place method. Just do method place, and it's going to take in an index where you want to place, and a player. And so it's pretty simple. We're just going to check if board index, and we're going to say if it's not 0, that means it's taken. So we're just going to stop the function right there. We're just going to return. Otherwise, we can set board index player. I believe that's what we can do. Okay, we can't actually do that, but what we can do is we can remove that index, and then we can insert at that index, like that. Okay, we actually have to swap index and player. And now, before we make a win method, we're going to make a representation method. So what we want to print out, what the board's going to look like in the console. So we're just going to do method. Let's just call this toString. And we're going to just do something simple. I'm thinking something like, I'll make a multi-line comment. Just like, and then let's say there's an X there, O there, X. Yeah, something like that. So this is going to be pretty easy. We can just iterate over each one. We'll have this output string. We'll just set that to an empty string. And let's just remove these barrier things. And if I remember correctly, the best to use is 2 spaces between each to make it as even as possible. So let's iterate over this. For I in this board, which looking back and I have to, oops, okay, I guess that's happening. But we need to change these to this board. So for I in this board, I never closed that. What we're going to do is first we're going to add to out. And this is a very clever method I'm about to do, where we have a dictionary. And so if it's 0, it's just going to be the dash. If it's 1, it's going to be X, I think we said is 1. Yeah. And if it's 2, we're just going to have an O. Then we do .I. And what this does is it's going to use this as sort of like a key. If I 0, it's going to be that. Then you can also just do, actually, if we wanted to, we can make this an arrow. And then just add the 2 spaces there like that. And then we can return out. I'm going to delete this comment because it's taking up a lot of space. And tab. Okay. Now let's test this before moving on. We're going to create a game function first. So game board game. No, oops. Board. First, let's try doing board to string. And then we're going to print this. Let's call the game function from here. Ooh, broken. Okay. Let's see. Why would it be broken? I'm not sure, actually. It's in the toString function. Okay, so the error was it doesn't like us using the underscore. Or at least we can use the underscore, it'll just make it very, very complicated. So we have to use the attribute keyword, and we have to wrap it in a lot of parentheses. So I just removed the underscores. So trying it now, it just returns a lot of O's. And first off, the reason for that is that it needs to be like the one thing, and it needs to be divisible by 3. So let's do this by saying like if what do we want to say? Check this divisible by 3. Well, actually, it needs to be divisible by 2. So 1, 2, 3, 4, 5, right? All right, we can just do if floating I plus 1 divided by 3. We want to make it so if it's not floating, which means it's completely rounded, what we can do out gets a new line like that. And so let's try running it now. Missing semicolon, found var. Yep. Error handling is kind of weird in this. So it seems to just not want to work today, which is my favorite. And it's actually because what we should do I represent 0 and size is board. Now the reason we want to do this is because of the fact that then we get the index and we can check if the index is divisible by 3. And then here we can just do this board I like that. So that's working, but some of this isn't. So let's just see what's going on here. Let's print this board I. Put 0, obviously, which means this dot that should be that. So I don't know why it's doing that. Maybe if I do... Oh, it's probably because of order of operations. If we do that, and then that, so that's adding 2 extra characters. Yeah, okay. Order of operations is always very important. If it saves, there. Okay, so now we have our beautiful board. I'm just going to bump this up to 3 spaces. Yes, okay. So if you're still confused for some reason, I'm just going to, it's fine. We get we're going to loop over each index 0 to 9. Well, since this is always 9, we can just do 0 and 9. Or, oh, it's because of the extra parenthesis. And to our output, we're going to use this key to see, it's just a simple dictionary. And we're going to get, if it's 0, it's going to swap out with that. I'm going to add 3 spaces to it. This is just because modulo isn't working right now. It basically checks if it's divisible by 3. So it's going to add 1. So if it's the third index, 3 over 3 is 1. It's a perfect round number. So it's not a floating number. So then we're going to add a new line. So it's a new line for every 3. Okay, so now that we've got the toString method, let's see if our place method works. Let's say we want to place, and in the first spot, which is going to be 0, since the rates are counting at 0. So we want to place an X. And then we'll place the board, we'll print the board one more time. Let's see if this is going to work. Yep, that works perfectly. Let's make them lowercase, just so they take up less space. That, yeah, now everything stays even. Now we can try placing, let's say, an O in the center, so 0, 1, 2, 3, 4. And boop. All right, beautiful, lovely. So let's start writing our game loop. I think for the place, we should return a value depending on if it works. So let's return -1, or we can just return, let's just return false if the spot's already taken. Let's return true if not. So we're going to instantiate our board. And let's say we have to write our win function now. So the win function is pretty simple. I'm just going to do method win. I'm going to take in a player. And what it's going to do is we're going to, let's make this variable I. And so we're going to loop over each condition in our win condition. So for condition in this win conditions, that's what it's called, right? Yes. For every condition in our win condition, we're going to run this code. Now our win condition, remember, is a list of indexes. It's like 1, 4, 8. That'd be 0, 4, 8. So we're going to want to loop over each index, and if all of them are taken, then we're going to want to return true. They did win. Otherwise, we're going to return false. So first off, at the very end of this, we're just going to return false because they haven't won if the code is still running. Now what we're going to do is we can go over each condition and just say for index in condition. Let's use an arrow and then just say I++. This is just going to increment I by 1. So for indexing condition, increment I by 1. And then if I is equal to 3, we can return true. So let's see if this explodes. Well, first we want to set I equal to 0 at the very beginning of all of them. So let's see if our computer catches on fire or not. I'm just going to put in 1. And it's... Oh, well, we're not printing it. But that's either means it's broken. All right. Oh, that's because I didn't actually put a condition. So we're just going to use a query for this, or we can... Yeah, we can put an if statement since it's one line. We're going to do if index equals player. And we're just going to do I++ like that. So let's try running now. False. That is good. But what if we place, what if they get the top row? I'm going to place 0, 1, 1, 1, 2, 1. Run. Still false. That's strange. Or, oh, it's because we need to get the index on the board. So if this board dash index is equal to player. True. Now let's say O took that last one instead of X. False. Now it's working perfectly. There's probably a bug, but we'll say it's working perfectly. So, while not board win 1 and not board win 2. And so this just means we're going to run our game. We're going to keep taking turns until someone has won. We should also make a stalemate. Let's do a method called stalemate. And this is just going to return, let's see. So we're just going to return true by default. But then inside here, we're going to for I in this board. And then we can do if I equals 0. That means there's still a place on the board. We're going to return false. All right, so this is a stalemate function. So we should also put and, not stalemate. Call for board. Also, I put dot here. Okay, now we've got this. We should print one last time. Board. Board to string. Print the board one last time. Now, this is kind of lengthy, and we're going to be using it twice. You'll see why we use it again later on. So let's just assign this to a very quick lambda. So we can do bake 1 equals our lambda like that. And so we can do, or we can change this to plain. And just every time we call plain, it's going to run this code and return that because of the arrow. So while plain, we're going to print the board. Then we're going to get an index. And we want to make sure this index is available. So let's make a new function. And we can actually define the function inside of the game. So we're just going to call this place. Then we'll take in, for our place function, we'll take in a player. So let's just call this index. And let's say it's equal to -1 by default. Now up here, what we're going to want to do is we're just going to place something we need to do is make sure that the index is between 0 and 1. So if index is greater than 9, or 8, or index is less than 0, turn false. Because this means the index is out of bounds. So while playing in our place thing, we're going to make a while loop. And we're going to do while board place index. And we're going to invert it. And this basically means while every time we try and place it, it's not a valid move, we're going to run this code. And since all we're going to do is we're just going to make the index equal to a number field, we're going to say what spot 0-9. We're going to subtract 1 from it. So we're going to say 1 through 9. And they're going to see this is the first spot, but that's actually 0, so we're going to subtract 1. So we can do place player like that. Oh, that should work. Let's try this. While place, so we're just going to do place 1. Then if not playing, it's not going to break in the middle of the code. So we're just going to have to put it after that and just break. That's why we have to type it twice. So let's save this and let's see how this goes. Okay, so we're here. We're going to do TicTacToe. On line 1, 2. Something's desperately broken. Let's see. Okay, I am back, and I don't know what the issue actually was. There was something going on with that, where it was not saving it, and so it was just saving it as a blank empty file. So I had to copy all the code. I restarted Mozzarella and pasted the code back in, and also I just wrapped it in this scope, which seems to have fixed it, and it worked. But there was this big issue where previously this was board place player IND, but it needs to be IND player. Now if we run our code, we have our TicTacToe board. We TicTacToe. Look at this. Someone wins and it's over. We've created TicTacToe in JPizza. Isn't it great? We had to use everything we knew. We used lambdas, we used functions, we used recipes. Isn't that beautiful? I'll see you guys in the next one.